So here's my completed prototype packs, and they are currently connected to my two relays, which I explained in one of my previous videos. So these relays will be able to switch the two packs from being in parallel into series. So right now I read 198 volts, so that's the voltage of each pack. They're connected in parallel right now, and if I switch on the relays, and now I have 397 volts. So now the two packs are in series, and I have the appropriate voltage, and that exactly matches the pack voltage of the Leaf when fully charged. So here I'll show you another thing I've got connected. This is a watt meter. It's a cheap hobby watt meter. I've connected this to the output, but only the negative lead goes through the meter. The positive lead, I have it connected only to the first 6 cells. So this here is reading the voltage of the first 6 cells, 24.9. That's not very accurate, but why I'm doing this is I want to know what's the maximum current. So this is cycling through, so this is watt peak, amp hour, watt hour, and amps peak. So this is the one that really we need. So as I'm driving, the current is going through the meter, but this only reads, because this meter is only good for 60 volts, I've only connected it to 6 of the cells. So even though it should read the full current going to the car, it'll only be calculating it based on the voltage of 6 of the cells, not all 96. So this should work. It's just as a pass-through. So if I need to, I can connect this directly to the Leaf pack. The reason I'm doing this is that I know that these cells, being that there's only 2 cells in parallel, it's not going to be probably drawing much current, but I'm just curious to know how much current is being drawn. If I'm driving for 2 hours and I completely drain this pack, theoretically that means it'd be pulling 2 amps average during those 2 hours approximately, but I won't know what's the peak. Obviously the pack and the Nissan LEAF is going to take the brunt of the load, but so this is more just hopefully it's just going to be pushing some energy into the packs at a gradual pace, but we'll see. Hopefully that will work. If not, I blow this meter and it's pretty cheap anyway, so I'm not too worried about it. Another thing I did here is I connected some balance lead again to only the first 6 cells. They don't sell monitors that are, well, cheap anyways, that I could monitor all 96 cells, so I'm only monitoring 6. Now this is the balancer that I used. What I'll probably use is this one here. So this one has an alarm on it, so if I plug this in and if one of the cells go below 3 volts, the alarm will go off, and therefore I can disconnect this pack from the Leaf pack if that were to happen. Now obviously if any of the other cells in the pack drop below 3 volts, they won't be monitored by this, but I'm not too afraid because I don't think I explained this, but when I built the pack, I took the best 192 cells that I've tested to now, and with Excel I said, okay, give me the top 192, but then these are the top 6 basically, from 1 to 6. And these are of the 192, these are the lowest cells. So it matched. I paired the strongest cell with the weakest cell of the 1 and 2. So obviously they're both very good, but this one is much higher. And what I've noticed is that I have quite a few cells that are really high compared to everybody else, compared to all the other cells, and therefore here I got these cells are the combined amp hour is 4.87. But if I go to the other end, the combined amp hour is 4.68. So I could have tried to make that more even, but this will work to my benefit because what I've decided to do is to monitor these 6. So technically, since they are some of the weakest of these cells, although like I said they're pretty good, that would result in, if one of these cells drop below 3 volts, these most likely will be fine. 3 volts is probably conservative anyways. They don't recommend that you continuously draw down past 3 volts, but that's for the life of the battery. It's not a fact of being dangerous. These cells will not have any problem with going down to even 2.5 volts. But I just want to manage these cells. Obviously, these, like I said, these are the best of the best, and therefore I want to try to keep them in good health. So here we go. So I'm going to disconnect all this and then connect it into the car and do my first real life test.